we're given the following problem, and what it is, if you notice, there's an equation, and no, we're not solving an equation, but what happens is, consider this is like an essay. This is the introduction of the essay, and then this is the conclusion of the essay. The purpose of the exercise here is to fill in the body paragraphs. Okay, so basically what they're telling us is that this right here equals this. All right, and our job is to prove it in between. We're supposed to show that this guy boils down to just this simple little guy right here. All right, now what we're going to do, we're going to make use of the trigonometric identities. All right, we're going to make use of those identities really quickly. All right, now let me show you which identities we're looking at. We're looking at these right here. All right, and we're going to make our life maybe a little more complicated, but then at the end it'll be super simple. Okay, so let's see here. What can I do? All right, I'm going to add fractions. So I'm going to forget for a second that this guy right here, this even exists. Okay, so I'm just going to forget that it exists, and I'm going to start off with this part right here. All right, so that's what I'm going to do. I'm going to say 1 minus the secant of theta over the tangent of theta plus the tangent of theta over 1 minus the secant of theta. All right, and I'm going to add the fractions. So in order to do that, I need a common denominator. So the easy one to do is this one over here on the right, and we're going to just multiply it by tan theta over tan theta. And over here on the left, we're going to multiply by 1 minus the secant theta over 1 minus the secant theta. And that's going to give us the common denominators. Okay? So, let's see here. I've got a binomial squared. So let's also write that in, what that looks like. A plus b squared is a squared plus 2ab plus b squared. Looks like that. And this would be your a, this would be your b. And in this case, it's minus. So that's not a big difference. This becomes minus then. And this right here becomes minus as well. Okay, and we're left with something that looks like that. Okay, so let's see what we get. We are going to get, on the left side, let's see, a squared is 1 minus 2 times 1 times secant, so minus 2 secant theta plus secant squared theta plus tangent squared theta. Okay, so that's from the right side of the addition sign. And then on the bottom, I'm not even going to bother to multiply them. I'm just going to write it as 1 minus the secant of theta times the tangent of theta. All right, just write it like that. And that should be okay. Now what we're going to do is we're going to say, okay, well, what identities are in play here? Well, I'm seeing minus 2 secant theta plus secant squared theta. Doesn't really look like much to me. But I see a 1 and a tangent squared theta. And if I zoom in over here on my Pythagorean identities, the tangent squared of theta plus 1 is secant squared theta. So let's go ahead and take a look at that. So we've got 1, we've got the tangent squared, 1 and the tangent squared there is going to give me the secant squared. So I have the secant squared, and I'm going to get the secant squared theta minus 2 secant theta plus secant squared theta. So 1, let me just point that out again. 1 and the tangent squared gives me this secant squared. Otherwise, this right here stays intact right there. All right. Now, let's see here. Divided by 1 minus the secant. Okay. Tangent. There we go. And what ends up happening here? Well, what ends up happening is these two can be combined. Okay. So we can combine those, and what do we get? Okay. We're going to get 2 secant squared thetas minus 2 secant theta over 1 minus secant theta tan theta. Okay? Now the next thing to do is, well, greatest common factor. You can factor out what these two have in common, and that is a 2 secant theta. So 2 secant theta will leave me with, let's see here. Let's think about this for a second. That'll leave me with a secant theta, it looks like. Okay, let me just be real careful before I proceed. Okay, actually, let me factor out a negative 2. All right, that would be more appropriate. Negative 2 secant theta. That will leave me with a negative secant theta plus 1. All right, I'm being real methodical about this. Okay, 1 minus the secant theta tan theta. Okay, now the reason for pulling out the negative 2, and let's just make this real clear that it's a negative 2 right here, all right, is because if you look at it, if I pull out negative 2, then this and this are exactly the same, all right? And that's really what we wanted to happen, because we want to be able to eliminate as much as possible. So 1 or negative secant theta plus 1 is the same as 1 minus the secant theta. And this crosses out, it's gone. All right, now let's move on. We're left over here with negative 2 secant theta divided by the tangent of theta. Okay, that looks a lot better than what we started off with. All right, now what we're going to do is we're going to rip this apart. We're going to rip this apart. We're going to take these two here. We're just going to tear them apart. And what I mean by that, we're going to write it as negative 2 secant theta times 1 over the tangent of theta. That's what I mean by rip it apart. Okay, we're going to take it apart there. We're going to get that. And now what we're going to do, we're going to use the identities. So let me go ahead. I'm going to stop real quick. I'm going to add in the identities. Give me 1 second. Okay, so now I've got the identities in place. Let's take a look here. I want to look at the identity for secant. First of all, secant is 1 over the cosine. All right, secant is 1 over the cosine. And let's see, 1 over the tangent is the cotangent. That's this one right here. Okay, so let's go ahead and rewrite those. All right, let's see here. That's going to be negative 2. So secant is times 1 over the cosine, and this one, 1 over the tangent, is the cotangent. All right, that looks good. We're getting somewhere. Now, let's go ahead and take a look at the quotient identity. The quotient for the cotangent is it is the cosine over the sine. So then again, we're going to rewrite this guy. So it's going to be negative 2 times 1 over the cosine of theta times the cotangent, which is going to be the cosine over the sine of theta. And what happens with the cosines? They cross out. They are gone, leaving us with negative 2 times 1 over the sine of theta But if you zoom in again on your identities and take a look here, 1 over the sine is simply the cosecant, and so our final answer becomes -2 cosecant of theta. And that was what we were supposed to show. If we look way back over here, give me 1 second. We look way back over here. Where was it? At the original problem statement. Right over here, that's what we were supposed to show, and that's exactly what we did. So that was quite a bit of work, all right, quite a bit of identities, but at the end of the day, we got what we needed. So there it is, and that's how we verified the trigonometric identities.